Friends, good morning to all of you. I am Professor P. Venugopal, working as an assistant professor in Electronics and Communication Department from Sri Sai Ram College of Engineering, Hanekal, Bengaluru. Today, I want to discuss about the PN junction diode from the module Semiconductor Diode and Applications. So, in today's session, I am going to cover the following topics: Introduction, PN junction diode, types of diodes, PN junction and operation of the PN junction. Introduction. Dear students, you are all aware about the materials, how the materials are classified. So materials are classified on the basis of the electrical properties as conductors, also called as metals, which allows the electric current flow. Second one is insulators. So dielectrics is the best example for the insulators, which does not allow electric current. Plastic, rubber are the insulators. Next thing is the semiconductors, where the conductivity lies between conductor and the insulator. Semiconductors are classified into intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductor, also called as pure semiconductors, and extrinsic semiconductor are also called as impure semiconductors or doped semiconductors. Extrinsic semiconductors further classified as N-type extrinsic semiconductor and P-type extrinsic semiconductor. N-type extrinsic semiconductor is obtained by adding pentavalent impurity atoms such as arsenic, antimony, phosphorus, etc. These pentavalent impurity atoms also called as donor impurities. Second one is P-type extrinsic semiconductor. This is obtained by adding the trivalent impurity atoms such as aluminum, bronze, etc. These trivalent impurity atoms also called as acceptor impurities. So in the figure, you are observing P-type semiconductor and N-type semiconductor. In the P-type semiconductor, holes are the majority carriers and electrons are the minority carriers. In the N-type semiconductor, the electrons are the majority carriers and holes are the minority carriers. As you know, N-type semiconductor is obtained by adding the donor impurity atoms or pentavalent impurities, so which donates the electrons, so that N-type semiconductor becomes positively charged. But P-type semiconductor is obtained by adding the trivalent impurity, also called as acceptor impurities. These acceptor impurity atoms accept the electrons and becomes negatively charged. Next is PN junction diode. You are all aware about PN junction diode. The P-type semiconductor and N-type extrinsic semiconductor, which are chemically combined using the fabrication technique, we get an electronic device called as PN junction diode. The diode is an active element and which allows the current to flow in forward direction and blocks the current to flow in the reverse direction. So what it consisting of? The PN junction diode provided with copper wire connecting the LEDs becomes an electronic device known as the diode. It has two electrodes. One is the cathode and another is the anode. Cathode is always negatively charged electrode and anode is always positively charged electrode. This PN junction diode offers a low resistance when it is forward biased and it offers high resistance when it is reverse biased. In the forward bias condition, the diode becomes short circuited so that large current flows and the resistance becomes low. Similarly, during reverse bias condition, the diode becomes open circuited, then no current flows and it offers high resistance. The circuit symbol of a diode is shown in the figure. So it is an arrowhead followed by the bar. The direction, the arrowhead indicates the conventional direction of current flow. The diode is forward biased, which means from the positive terminal through the device to the negative terminal. The P side of the diode is always positive terminal and it is termed as anode, as I told you already. And N side is always a negative terminal and it is termed as an cathode. The PN junction diode can be destroyed when high level of forward current over its device. Similarly, large reverse voltage causes the junction to break down. Next thing is types of diodes. We have three types of diodes classified based on their forward current and reverse voltage capacity. The first classification is low current diodes. So where the forward current capacity is up to 100 milliamps and reverse voltage capacity is up to 75 volts. Second category is medium current diodes, where the forward current capacity is 400 milliamps and reverse voltage capacity is 200 volts. Third category is high current diodes, where the forward current capacity is few amps and reverse voltage capacity is several hundreds of volts. PN junction. What is PN junction? As I told you, P-type material and N-type material which combined chemically by using fabrication technique. So we get a junction called PN junction. So you are observing in the circuits when from the P-type, the holes are trying to cross the junction, and from the N side, electrons are trying to cross the junction. The PN junction is formed when a single crystal of semiconductor is added with acceptor impurity on one side and donor impurity on the other side. Left side of the material is a P-type semiconductor having acceptor ions and positively charged holes. Right side is the N-type semiconductor having donor ions and free electrons. Due to concentration gradient across the junction, charge carriers move from high concentration area to low concentration area to maintain the uniform distribution of the charge. Initially, the distribution of the charge carriers is not uniform. To achieve this uniform distribution, the charge carriers has to move from high concentration area to low concentration area, and this process is called as diffusion. And the diffusion of the charge carriers takes place on either side of the circuit as shown in the figure. So when the migrating electron diffuse into the P-type and recombines with the acceptor atoms on the P side, the acceptor ion accepts the additional electron migrating from the N side and becomes negatively charged immobile ion, and the hole disappears. See, when a hole diffuses into the N side from the P side, they recombine with the donor atom. This donor atom accepts the additional hole and becomes positively charged immobile ion, and therefore the electron disappears. The formation of the immobile ions near the junction is as shown in the figure. After diffusion, negative ions are formed on the P side and positive ions are formed on the N side. Depletion region. What is depletion region? In between the immobile charges at the junction, you observed two types of immobile the charges. So one is the negatively charged immobile ions on the P side, and another is positively charged immobile ion on the N side of the junction. There exist no charge carriers. See, in between the immobile charges at the junction, no charge carriers exist. Such a region is called depletion region, and this depletion region is also called a space charge region. This depletion region prevents further movement of electrons or holes across the junction. On the N side, depletion region consists of donor impurity atoms which have lost the free electrons associated with them and become positively charged. This already told you in the beginning. On the P side, the depletion region consists of acceptor impurity atoms and becomes negatively charged by losing the hole associated with them. Next, the parameter related to this PN junction is junction barrier voltage. Dear students, observe the circuit diagram. So positive immobile ion is formed on the N side and negatively charged immobile ion forming on the P side. In between these two immobile charge carriers, there is a layer called as a depletion layer, and the region is called depletion region. So negatively charged ion is having the negative polarity, and a positively charged ion, immobile ion having the positive polarity, and this sets up the barrier. That barrier is called as a junction barrier, and the voltage of this junction barrier is called junction barrier voltage. Next thing is that how the PN junction diode is working. The PN junction diode is operating under three different cases. First one is under no bias, second one is under forward bias, third is under reverse bias. Let us study one by one. So what is the PN junction diode under no bias condition? Means unbiased condition. You are observing the unbiased the condition of the PN junction diode, where the p-type semiconductor consisting of holes are the majority carriers, and n-type having electrons are the majority carriers, and the holes from the p side are crossing the junction to the n side, and the electron from the n side cross the junction and moves to the p side as shown in the figure. Under no bias condition, the positive charge on the n side repel the holes to cross the junction from p to n side. So negative charge on the p side repel free electrons to enter from n to p side. So because of this, barrier is set up against further movement of charge carriers, and this the barrier is called potential barrier or junction barrier. So please keep this point in your mind. Potential barrier is of the order of 0.7 volts for silicon and 0.3 volts for germanium. Practically speaking, it is 0.6 to 0.7 volts range and for silicon, and 0.2 to 0.3 volts range for the germanium. The form of potential energy barrier against the flow of electron from n side across junction is shown in the figure. Similarly, potential energy barrier against flow of holes from the p side across junction is also shown in the figure. Next type of PN junction is forward biasing of PN junction. PN junction is said to be forward biased when the positive terminal of the battery is connected to p side and the negative terminal of the battery is connected to n side. So observe the figure. So there are two materials, p-type materials, n-type materials. In between, depletion region is there. Positive polarity of the battery is connected to p-type and negative polarity of the battery is connected to n-type. Since the p-type is connected to positive polarity, p-type is positive polarity, the what happens? The holes which are repelling from the positive polarity and moving towards the n-side region, these free electrons gain sufficient energy from supply and they move to the p side, but some electrons enters into the depletion region and recombine, and the majority of the free electron migrate into the p side and reduces the potential barrier. So in the figure, positive polarity connected to p side, which means holes are repelling from the positive charge, and similarly negative polarity is connected to n side. Then n side means electrons are repelling from the negative polarity. Then what happens? The electrons so moving from the p side, n side to the p side, and the holes are moving from p side to the n side across the junction. If the applied bias voltage progressively increases from 0, the barrier potential gate progressively decreases until it effectively disappears, and the charge carriers easily flow across the junction. Holes move from left to right and electrons move from right to left, hence resulting in a large current flow called as forward current. This forward current is the sum of electron current and the hole current. Next, reverse biasing of the PN junction. So in this type, you are observing negative polarity of the battery is connected to p type and positive polarity of the battery is connected to n type. See, since p is connected to negative polarity, so what happens? See, the holes are attracted towards the negative polarity, and similarly electrons are attracted towards the positive polarity, and which creates the large depletion region, which is shown in the figure. So on the application of the external bias VR, holes from the p side are attracted to the negative terminal of the battery and electrons in the n side are attracted towards the positive terminal of the battery. Since both the majority carriers move away from the junction, the depletion layer gets widened. The wider the depletion layer, the greater the difference in the potential across the junction, which is also shown in the figure. When VR increased, the barrier potential also increases, but when the barrier potential is equal to the supply potential VR, then the barrier stops growing. When this happens, majority carriers in the N-type and the P-type stop moving away from the junction, creating an electric field. Some minority charge carriers recombine with the majority carrier with the forming, and very small magnitude of current I0 starts to flow in the electric circuit in the direction opposite to the conventional current. So this I0 is also called reverse saturation current. The last content is VA characteristics of silicon germanium diode. So which shows both forward and the reverse characteristics. Forward characteristics is the graph of forward voltage versus forward current, and the reverse characteristics is the graph of reverse voltage versus reverse current. So forward biasing, with the positive polarity of the battery is connected to P side and the negative polarity is connected to N side, then up to the threshold voltage, the current is constant for the various values of voltage. So once the voltage crosses the knee voltage or threshold voltage, the current linearly increasing with respect to the forward voltage, which is shown in the figure. Similarly, in the reverse characteristics, so till the reverse voltage, so the reverse current remains constant. Once it crosses, the applied voltage crosses the reverse voltage, what happens? The current which increases rapidly, so that the diode may get destroyed. So thank you for listening and watching this video.